Boa tarde, pessoal. Já são 4:02, a gente deve começar nos próximos 3 minutinhos, tá?
Good afternoon, my friends. Dele, we are going to start in 2 minutes. So, okay. Then we also have a live on YouTube, so if you want to share the link with someone.
You also have?
Yeah, very organized, my friend.
I didn't get that.
Vanessa, can you share with him the link on YouTube?
João will do that.
Okay.
He's with us. João?
Okay, because I'm already sharing, yeah? So...
Oh, nice. Just a moment.
I'm already sharing my slides, so I hope it won't disturb the person who is going to share.
Okay, we can also, okay, because we are going to, okay, can we also make it be online on YouTube also, Dele?
Yeah.
Okay.
So what time is it in
4 and 4.
All right, 4 p.m. Okay.
4 p.m.
It's
evening.
10. It stands over there.
7, yes, 7 p.m.
7, 3 hours.
It's
3
not
hours.
too bad. It's not bad.
Oh, that's great.
Yeah.
I think that we can start so that we cannot delay any longer. Okay, excellent. Good afternoon, everyone, and good night, Professor Bamidele. Now, I'm pleased to have invited Professor Adebisi to join us and to give us a talk to our INERGE webinar series. And much more happy, pleased, because I'm delighted because Professor Adebisi could accept our invitation. Professor Adebisi and I are colleagues, maybe for more than, we met maybe 8-9 years ago, right? Or during a conference? Yes. And nowadays, Professor Adebisi is a full professor in intelligent infrastructure systems and also director of a smart infrastructure and industry research group at Manchester Metropolitan University. Professor Adebisi received a master's degree in advanced mobile communication engineering and PhD in communication systems, both from Lancaster University, UK. Professor Adebisi is from Nigeria. He has been part of a multi-partner, multi-country, multi-million pounds project as investigator funded by the EPSRC, Innovate UK, among others. He has a strong record of accomplishment of attracting industrial-related grants through knowledge transfer partnership. One of the such projects received the UK Best KTP Project of the Year award in September 2020. So, Professor Adebisi, the word is yours. And once again, thanks so much for accepting our invitation and sharing something new with us.
Thank you very much, Professor Moses Rivero. It's a great privilege to be here. I believe everyone can hear me clearly. Yes?
Yes.
Okay,
Yes.
great. All right, thank you very much. So it's a great privilege to join you. I really want to thank my friend and my colleague, Professor Moses. I was at we met 2008 at a conference. By 2013, I think we are already at Juice de Fora at his conference as an invited speaker. And by 2014, I was back as visiting professor. I spent 1 month in his lab. And since then, we've been in touch, so which is really good. So, this evening, which is your afternoon, this evening, I'll be talking about the complementary roles of people and technologies in future cities. What that really means in a simple term is I'll be talking about technologies, I'll be talking about some of the projects that we've been involved in, but I also want to finish by saying without people, there's really nothing smart about the city, because the city will always be as smart as the people that develop it. And so people are very critical to the development of our future cities. So I will start by basically talking about our research group, talking about a few projects that we've done. And most of the examples that I'll be giving will be about practical projects that we have done within my group. So because this is something that we understand better instead of using example outside of what we've done. So thank you once again for your attention. So what is smart infrastructure research about? So at Manchester Met, we have a group, and I'm the director of that group. It's known as Smart Infrastructure Group. This group we have 3 core areas that we specialize in. So the first one is it's known as connectivity. So these are guys who look at Internet of Things, 5G. We also look at artificial intelligence in the area of data analytics. We have the second group of people that are looking at smart energy systems. So they are not power system, but they use innovative technologies like IoT and data analytics and other embedded systems to manage energy. And the third group of people, they are mathematical modelers. So these people are mathematicians. They apply mathematical software and algorithm in solving societal challenges in what is known as digital twin. So a digital twin is a software replica of a physical asset. So if you have an asset, it could be a building, a hospital, a house, whatever it may be, you can create a software version of that physical asset, which becomes the digital twin. So they are like twin. So these are the 3 areas where our work are kind of focused. So this is an example of what a work that we did, where in this project, we were approached by a company called Cyractech. They had an issue, a security challenge with their IoT devices, and they asked us to develop a new vulnerability assessment tools for IoT. So we developed that. So that tool is able to identify, vulnerabilities within any ports or any IP-based devices. And that was working really very well. And then they gave us additional funding, a PhD match funding. So university pay half, and this company pay half for that PhD. So this PhD student work on artificial intelligence to kind of improve what we did initially, which was not really as smart as AI. When we completed that, now we are looking into the next phase, which is actually creating a digital twin of a whole smart city with an IoT, and we're kind of creating a digital twin of that, so that the advantage of digital twin is that research that you cannot carry out in a physical asset, you can carry it out on a digital twin, and then do things like preemptive cyber attack and so on. So another example of a project that we've done is, this is a Innovate UK project, which, KTP, knowledge transfer. So this type of project here, this is called Standpipe in the UK. It's actually in Brazil as well, because we are now talking to some people in, I think is, I forgot the state in Brazil. So this is a pipe that people put underground to tap water, whether if you are cleaning the street or if you are doing construction. So it's usually a mechanical standpipe. So what we did was to convert it to a non-mechanical standpipe. So we made it smaller, smarter, and it's not only telling you how much water you use, it actually gives information about the location of the people using it, the pressure of the water, quality of the water in terms of whether there's hydrogen, too much salt, biochemical, name it. It was really very, very good. And because we have multiple sensors in it, we also develop a system that's able to optimize the performance of the sensor arrays in the embedded system. Then, the communication system we use, we improve reliability and increase signal rate. That project, was kind of granted outstanding when we finished it. We completed it after 3 years. And among 800 projects across the UK, it won the best project of the year in 2020, as we said. So our university is actually top 5. We have 31 knowledge transfer projects, which makes us top 5 university in the UK to be awarded grants by Knowledge Transfer Partnership, which is really a very good thing. So going to my topic today about smart city. So I'm sure you've heard a lot about smart city and so on. And sometimes people ask, what is smart city really? So smart city is very simple. It starts with acquiring data from the city, and that data usually it doesn't make any sense. It's just raw data. You want to convert data into information. But in order to convert that data to information, to acquire the data, you have to do some sensing, which is you use sensor to kind of acquire the data. But the data itself doesn't make sense. You take it to a particular area where you need to gather information from the data. Hence, you need communication systems. So, and then because you perform some analysis on the data, digital, whether we are AI or any kind of algorithm, so that information becomes knowledge. Because knowledge is now, okay, this is why it is hot. This is why it is very cold. This is why it is too high. It is too short, whatever it may be. So you now have knowledge. But knowledge itself is no good. If it is too hot, what do you need to do? Well, I want it to be cold. Then it becomes wisdom. So really, in a smart city, you acquire data, you convert that data to information, the information becomes knowledge, and the knowledge where you cross-correlate it with several other sources, and then you make an intervention, a closed loop of that, you have wisdom. And that is really what you want in a smart city. It's not just about data, it's about how you use the data to make informed decisions. So for us as a university and my team specifically, we're very privileged because we are on a road in Manchester known as Oxford Road. This road is particularly special, very unique in the sense that there are one of the two largest universities in the UK are actually on the same road. There's also one of the largest hospitals. There's also one of the largest Royal School of Music in the UK, and among others on the same road. So actually on this street alone, you have almost 100,000 students at any time. So in Europe, it's one of the largest coming together of students in Europe. So, and so many buildings, so many businesses around the area. So we kind of started in 2016, 2015 to use this as a demonstrator for smart city. So we use that city to say, okay, can we research how a smart city should look like? So first and foremost, we awarded 10 million by the UK government, and 6 million comes from industry. 10 million from UK government in pounds, 6 million from UK industry. So we have 21 partners. The lead of this project is Cisco. And these 21 partners, we kind of demonstrated IoT for smart cities. So we connected sensors to bikes, to trams, bus stops, even light fittings like lampposts like this, buildings, all sorts in the city. And then we use that to kind of we have various use cases trying to say, okay, how does this affect health? How does it affect people's well-being? How does it link with research and so on and so forth? And then again, on the same street, we are privileged also to be part of another project. It's called Triangulum. So the previous project is called CityVal. The second one is Triangulum. This is a European project. We're given 29 million euros. We have 22 partners over 5 years. So again, on the same kind of road, we optimize some buildings. We bought a few electric vehicles. So actually 2000 and I would say 16 or so. So I bought the first 2 electric vehicles at the time. At the moment, my university now has 12 because now they no longer buy non-electric vehicles. So anytime our car becomes too old, we buy only electric vehicles. So we also have some cargo bikes. Cargo bikes are electric bikes that move maybe things like food from one part of the campus to another. They move stationaries like books and things like that in the library from one part to another. And then we work with Siemens, one of the world's biggest integrators and an innovative company. We work with them to create something called central controller. Central controller is called virtual, you can call it virtual power plant as well. So it integrates various energy sources, energy available from solar panel, from electric vehicles, and is able to turn things down and on as required automatically without anybody's intervention. So this project was really very successful. So we use one part of our campus. So remember, the project covers the entire city, all right? So the whole of, no, not city, sorry, the whole of this road, the Oxford Road. And based on this project and this project, we use one of our campus as a test bed. Now, what is unique about this campus? This campus is called Baileyfield Campus. What is unique about it is that it's brand new. It was completed in 2014, 2015. So there are 2 faculties here, very large building. And then we have student halls of residence around it, about 1,000 students. And then we have an energy center next to it. So this is the energy center. It contains combined heat and power. It has underground water. It has so many energy innovation. Then on this building, we install solar panel, as you can see. And then the car park next to the building, we have 18-point electric vehicle charging units there. And all these are connected together. And then we have this large battery, about 500 kilowatt hour. So we use all this. So basically, the whole of this campus, the aim actually was to be able to take them off the grid and still be able to go on. So you can manage this off the grid. So it's really very interesting project. So actually, because of all the intervention and this technology that we installed here, this project won that building won the Public Building Energy Project of the Year in 2018. So this is a platform that we now have. So that platform has information about on that street and even across the street in the city, energy usage, air quality, and so many things. So from that, we have something called data platform Manchester Eye. We have got other partners got additional funding to be able to improve on what we have done. Okay, so that's one thing that we did in the city. We use IoT, we use energy intervention from PV to solar panel to electric bikes, electric vehicles, and then we have things like large batteries and so on. And then we use integrated system to create a platform where you can actually optimize the use of energy in a building. And then while that was going on, we were awarded by the EPSRC. EPSRC is Engineering and Physical Sciences Research Council. I'm sure we have something like this in Brazil as well. They fund the university with fundamental ideas, something that is major discovery. So we were given 2 million in total, but 1 million goes to the UK, 1 million to South Korea. So the aim of this project was something known as peer-to-peer energy trading. By peer-to-peer energy trading, it means how can you, if you are like a household, so this house, for example, if you have solar panel and battery, how can you generate an energy, consume what you generate, and when you have too much, how can you share it with your neighbor or sell it to your neighbor? That's what this peer-to-peer energy trading and sharing is about. So it's basically Uber for energy, or you can call it Airbnb for energy, or any concept, that is more like you generate something, or Amazon or something like that, where you have a book, you don't have to go to bookshop, you can sell it to somebody on a platform. So that is what we created. So actually working with Oxford University, Imperial College, and University of Bath, so my team worked with them to create, that platform. And then South Korean, they have 5 other partners as well that work with us. It was really a very, very successful project. So our part of the project is we looked at the distributed communication system. We built a new algorithm to minimize communication delay and loss of transaction messages. That was really good. We published in high impact journal. We also created a prosumer matching. So the participants on this platform, how do they match? How do you know that I want to sell, I want to buy? How do you match them? And actually we optimize the path through which you route your communications and so on. And our result shows that we are able to reduce cost by 15%. Again, we work with the energy trading platform. So in the energy trading platform, we look at something called double auction energy trading system. So we design a system that is based on market distance and network constraint and utilization maximization. What that means is basically, if you generate, the good thing with generating and consuming energy locally is the fact that you don't have losses that you have with generating far away and then transmitting over a long period of time, which is good for the environment, is good cost-wise. It's just excellent in all round. So we're able to develop an algorithm that takes distance of travel of energy into cognizance, which means that when you are generating far away and trying to sell it to somebody who is far away from you, you are penalized for that, and so on. So again, we published that in IEEE Internet of Things journal. And then, this is like, I don't know if you can see that. Yeah, so this is how people in the platform, the interface of the platform. So how, if you have 10 people on the platform, for example, somebody Mr. A wants to sell to Mr. B, or Mr. A has 5 kilowatt, but actually Mr. C, D want to buy only 1 or 2. How do you share among them, and so on and so forth? So we're actually able to design an algorithm that make that possible. Yes, we are partners of about 4. So Oxford, Imperial, Bath, and Manchester Met, our team, but this is the area where we contributed. Now, this is getting interesting, because if you understand, like I said, there will be something like this in your country as well, where government fund fundamental research. So the idea here is that you groundbreaking, something that you can get a patent, something that is really very good, you publish good papers. But sometimes it stops there because you don't take it to market, you are not working with industry and so on. But we are really very privileged that as we're just about finishing that project, we got another grant with UK government as well. So we partner with a company in the UK and one company in Nigeria. As Professor Moses said earlier on, I'm originally from Nigeria. It makes that a bit easier, not easier, but it makes that interesting, I would say, because we were able to then take what we did in that IPSRC project, we took it to Nigeria to develop what we call NICE, Nigerian Intelligent Clean Energy Marketplace. So what that means is that we develop a system where we're able to connect people in a community together, and then we try to see whether what we develop in theory can work in real time, in real environment. So this is what happened there. So there's a school, a private school. So in the private school, we installed some solar panel on their roof. We put some batteries and so on and so forth. And then we selected 10 buildings around the school. And this 10 building, we install solar panel on some of them, install some batteries on some of them, and so on. So, and then we connected all of them into our marketplace, what we call our peer-to-peer marketplace. So during the day, for example, that's an example, the school needs energy, more energy. Instead of using diesel generator or using power from the grid, this is more expensive and it's not green. The one from the grid is also not green as well, maybe less expensive. So what they do is that the people in the village, people in the houses around the community, maybe they've gone to work or they are in, they are not home, or they are using less energy than they need. So we can tap into their energy, the green energy here, and use that to supply the school. At the school, by later in the evening, they've reduced a lot of energy usage in the school, and the community can then tap into the school power system and then use the energy. And because it's all smart metered, at the end of the month or so on, people kind of get paid for supplying excess energy, or they will pay a little bit of money when they have used more than so this is the school I was referring to, and this is like the picture of the village near the school. So we connected them. So these are some of the things that we install at the school. Some of the smart meters. So in order to have control, we kind of put all the smart meter in a particular enclosure, but each of these smart meter actually represents a house. So we finished that project about 2 months ago. So I was actually in Nigeria to launch this. So it was really a big, well-received project. We were funded by this government Department of International Development, and the company in the UK is called Q Energy. The company in Nigeria is called Via Energy. So that's the platform. It shows you who is using what energy and how much you have to pay or receive at the end of the month. So these are some of the gateway that we develop, and that's the smart meter that we use. So now, this is the project in Nigeria, but actually in the UK, we created a replica of that, a small replica of that in my lab. So this is the roof of my lab in the UK. We install solar panels similar to the one installed in Nigeria, right? And then we have inverters and everything that they have in Nigeria, maybe smaller version, the smart meters as well. And we created a similar thing in my lab. And the aim of that is that we are trying to create a digital twin of this in a software. So we use a software known as Opal, and that software is able to. So the aim is that, remember that here we only had money, right, to look after 10 buildings, and there's only one big school. Imagine if somebody asks you, if an investor then asks you a question, well, if I have an estate or a community and there are 50 buildings, all right, how much will it cost? What do we need to do? And so on. This cannot answer that question. This can only answer the question of how can you do it in a 10 houses and a very big school. So what we are doing right now, as the project has finished, is we've bought a platform, a kind of hardware called Opal Real Time. Is connected to this, and we are using that to develop an algorithm that will be able to tell us how to scale it up. If you have 50 buildings, how can you, trade and share? What is the optimum thing? So we are doing that right now, and this is part. So some of the output of that. So it's showing the power flow from different houses. It's showing, everything going on in the community and so on. So as I'm kind of rounding up, so electric vehicle is going to be big. It's very, very big. In the UK, for example, they've stopped manufacturing of anything that is diesel. That will be stopped soon. It's actually been stopped sooner than the government wanted it to happen. So if you look at the household in the UK, average household in the UK consume about 9 kilowatt energy, 9 kilowatt hour. But Tesla has 90 kilowatt hour, for example, which means one Tesla can power maybe about 9 houses. So if you have 2 Tesla on your street and there are 20 houses on that street, maybe 3 Tesla that goes to work in the morning, charge using renewable at the car park for 8 hours, come back home, can basically supply all of your electricity. And they've started doing that in the UK. So this is electric vehicle is going to be a very virtual power plant that I mentioned earlier on. It's going to be very big in the next coming years. So we are investigating that. We are looking at opportunities of different cars have different characteristics, different behavior. How do we charge them and the charging system and the people that are using them? And how do we connect them to university, airport, different facilities? And, how can we also work with the grid so that we can create a business model that make everybody want to be involved in this electric vehicle? So that electric vehicle is not just about a car, it's actually an investment. There's something called arbitrage. So in English language, arbitrage is when you buy stocks, for example, you buy it when it is cheap in stock market and you sell it when it is very expensive, so you make money. That is arbitrage in economics. So what we are looking at now is arbitrage, where you drive your car to work because you don't need it for the next 8 hours. You are not in rush to charge it. You say, well, charge it when the electricity is cheap, and you buy it at maybe about 5 pence per kilowatt in the morning. You get home in the evening because everybody needs power at that time. You can sell it at 10. So you are basically making money from your car batteries and so on. So we are looking at that. We're also looking at, remember I talked about peer-to-peer energy trading. Our understanding of connectivity and using IoT, when we connect different sources of energy in the city with the cars and all that, how can we do peer-to-peer trading? That's one. How can we create value, transaction, so that people are not just selling? So if I sell excess energy to you, maybe I don't need money. I could say, well, I invest that in the market so that we can use that to improve the market. So that could be your pension, that could be your contribution savings for the future, and so on. And you get interest as a result of that because you are investing. That's the future really of what we are looking at. So as you can see, energy or smart city, if you pick one, the first one I spoke about was about water. The second one I looked at cybersecurity and IoT. Then broadly, I've looked at energy now and connecting it to mobility, electric vehicle, connecting it to pollution as well, because as you reduce all this, it affects the pollution and so on. There's also the idea of climate change, all this affecting climate change. So you can see that actually all this is not just about technology, it's about people. So when we talk about sustainable cities and infrastructure, what we're actually talking about is not the infrastructure itself, it's not about just sustainability, it's about improved outcome, improved overall well-being and quality of life. What is important is that the quality of life of people are improved, all right? Because if we have sensors all around and then the well-being of people are not improved, then it is all useless. So example of well-being is job creation, for example. So people must have job. There must be peace of mind. People should feel secure. So people ask me a question when I kind of present about cybersecurity, for example, and I talk about IoT and so on. So, the problem of IoT is that it makes us more vulnerable. It causes, there's so many cybersecurity issues. And I say, well, for me, if you install anything in your house, all right, and it makes you less secure, that thing is bad. It is not good, because really, whatever that you install, it costs you money, it costs you time, it costs you efforts. And this should improve your quality of life. And by the way, security is a measure of quality of life. If your quality of life reduced because you have installed a new IoT in your house, then that has reduced your quality of life. So really, it's worth not installing at all. So the point I'm making really is that IoT and all these things, they are not meant to reduce your quality of life, they should improve them. And part of why they are currently not doing that is because of the involvement of people. So remember, earlier on, I kind of said, you acquire data, okay, by sensors, you collect this data, and you use communication and data analytics to send them to a particular point where you do analysis and so on. And that gives you knowledge. But that knowledge gives some decision making, helps the decision making, and then you are able to control and optimize. Meaning you can turn it down if it's too much, you can make it up if it's too low, if it's too slow, you make it fast, and so on and so forth. So that's where control and optimization Okay, but really, this is where the citizen comes in. So what data we should collect? How should we collect it? What is it about? We need to engage with the citizen to make that possible. The people must be at the heart of it. The people should be at the heart of what is needed. And then that helps, the government, which also the people, because the data that we give them, we help them in making decisions, making laws that helps us automatically in the end. So that as we engage with people, we help with decision making, and of course, ultimately, we have sustainable city, we have a sustainable environment. So some of the proposition that I have is that maybe we don't call our citizen engaged citizen anymore, because engagement means I want to develop an idea. I look for Professor Moses and his team or people on the street, and we say, oh, I have developed this. Okay, what do you think? Is it a good thing? That is not good enough. The people that want to use the technology should not know about it only when it has been developed. They should be part of it right from design, right from the concept. So that is why they are no longer engaged citizens. They should be proactive citizens. So the citizen, you don't call them users anymore. Oh, they are using it. No, they are designers. They should be part of the design right from onset. So we call that democratization of decisions. So you democratize the decision about where, how, and what technology that is to be used. Okay, so that is going to be very, very important in our future city. And the UK is actually doing that. So for example, the net zero decarbonization report of the UK shows that they are engaging with the citizen, they're doing a lot of things. That means it is not just about trying to be green. It is not just about trying to make your city smart. You should also think about the money that you are spending. You think about the environment. You also think the fact that you are creating jobs. So for example, we have COVID. Okay, coming out of COVID and be better should not be something that is going to destroy economy. It should be something that should make economy better. So in the UK, for example, they call it leveling up, meaning that yes, there's COVID. Yes, we want a green environment. We want a smart city. Actually, it should make life better. It should create more jobs. You should create policy that makes that happen. And that is what they are doing, So they are installing so many, we're spending several millions, creating about 60,000 jobs, hydrogen, and everything that they're trying to do, they are linking it one way or the other to creating jobs, creating businesses, so that it is not about having good economy, all right? So it's not about like competition between, say maybe, okay, you have good economy and bad climate. No, it is both good economy and good climate. So, and there's consensus, cross-party consensus. So it's no politics. It's not one party fighting against the other party. No, it is really joint ideas by all the people involved. So finally, as we can see, there's a lot of measure that, for example, people are doing across the city. So ours is just an example of how we have used technology to influence how smart our city can be. Students are working with the database that I just showed you earlier on. They are acquiring data from that database, creating apps, creating ideas about how to effectively monitor what is going on in our city to make life better. But you can see that this is not just about technology, it's about the people. So the smartness of a city is not measured, it's not just going to be measured by the technology. It's going to be measured by the inputs it gets from the public, because the public will inform what they really need. The smartness of a city will be determined not by how all singing, blinking, and everything, but more about how it has taken into account the well-being of the people, that people's lives are better in the end. So finally, I will just leave you with this quote, that smart city is a concept. So when you hear about smart city, it is a concept. It is a journey. And it's like a journey that maybe you will never get there. So the reason for that is that, people's expectation, people's requirements, people's lifestyle will change. Our challenges will change. And you see, smart city of the future will continue to adapt to meet our expectation, because our expectation is not static. it means that smart cities will never be static. Smart city will also always be what we define it to be at a particular point in time. A practical example of this is, 2 years, 3 years ago, 5 years ago, when we started this smart cities project. If you ask us the most important thing at the time, we will tell you climate change, we will tell you we need sensor to see energy efficiency in building, to turn things on when it is not necessary, comfort of the people, and so on. We will tell you that was very important. But as you all know, with COVID, we realized that pandemic become extremely important. So actually, future city, any smart city now will be a good city that can identify maybe pandemic quickly, that is able to isolate people, that is able to do X, Y, Z. We don't know the challenge that we're going to have tomorrow. So the smart city of tomorrow should be able to address that. Hence, expectation of people as it changes, smart city concept will change. So it's a journey, and maybe we never get to the end of that journey. So people are very, very central to development and the innovations that are going to happen in the city of the future. Thank you very much.
Danny, thanks so much for your talk. It's a very nice talk, because you give a good picture about your research related to this smart city. And for me, it was very nice to see how big are the projects where you have so many partners. And I think that it's what smart city means. Many people, a lot of companies, okay, but now it's time to leave the people to ask you something. Otherwise, I will, keep you just talking with you, but we have time in other opportunities, right?
Yes.
So first of all, Gilmar, hello, Gilmar. He wants to talk with you. He has raised his hand for a while, but asking to make your question at the end. Okay, Gilmar, please go ahead.
Hi, Professor. Professor, I would like to know about what you think about the difference is going to be in we start having the quick charge stations for electric cars. What the difference you see in what is going to be used in Europe and what's going to be used in countries like our country, like Brazil and Nigeria? How do you think will be the difference between this different worlds we have? Europe is preparing for a really fast change in the way the cars is gonna put an end to the fossil fuel and everything. But we think that this reality is still a little bit far from us, from countries that share common things like Brazil and Nigeria, same population. We have the same wind power possibilities, and they're very similar countries, but completely different from the reality in Europe. What do you think is going to be the biggest difference?
Yeah, I think I agree with you absolutely. Like I said to you, I just completed that project mostly during pandemic, during lockdown, but we were able to finish it. But I went to Nigeria to launch it, which was really very good, very successful. And in my talk, when I was interviewed on the TV, radio, newspaper, everywhere, they asked similar question. Oh, this is happening in China, this is happening in Europe, but we're about a bit lagging behind. And the fact there was this guy on the parliament, this is an MP, member of parliament. He said it boldly to say, oh, we are oil producing country. We are going to kill the electric vehicle. I just look at the guy, something is wrong with him, because you see, the world is not going to wait for you, wait for us, brother. This is the reality. We try to do this with communication also. So when mobile phone came, because we are used maybe to landline, we are hoping that, it's their problem. No. But actually, when Nigeria, as an example, woke up and thought we want to do this communication very well, people actually has more mobile phone in Nigeria than the UK. The density of mobile phone in Nigeria is higher than United Kingdom, higher than America. And the reason is not because they are richer. The reason is that they did not have legacy. They didn't have landline. Not many people have landline, and they get tied to a big company before, so they can start from scratch. And I think the same with electric vehicle. Okay, actually, with electric vehicle, I think what we should be doing is to begin to embrace it and innovate with it. Because number one, how many countries in the world have Nigeria and Brazil that you say we don't actually manufacture a lot of cars anyway? We depend on these people for many of the cars that we use, especially the rich. We drive BMW, we drive Toyota, we drive all this. Okay, so if they stop manufacturing diesel car and petrol car, there's nothing you can do about it. You have to buy electric vehicle anyway. So we don't have to wait until we get to a point where we are desperate. I think this is a good time to start thinking about it. Having said that, as somebody who is from a country like Nigeria as well, I am sympathetic to our nation. And the reason is that, look, America and the UK and Europe, they develop their nations with non-green energy. Okay, we're using coal, they develop their nation. And then when we have the opportunity, maybe because and that is cheaper, that is easier. When we have opportunity to develop now you want to go to something that is a bit more expensive and something that you have been developing a long time ago at the background, which we didn't have capacity. So it's not equal, to be fair. It is not very equal at all. But look, it has never been equal. It will never be equal until we, like America, China is doing. China is stood their ground and they are trying to make it equal. Nobody is going to come to us and make it equal. Nobody is going to come to us and say, I want to make your life better. We have to stand to say, we have to make, and this is my message to Nigerians when I go in there, that let's not wait for somebody to come and give us food. We have to be on the table saying, I deserve this, this is what we need to do. But we cannot wish it away. We can't say, oh, I don't need the electric vehicle. I will do this, because you don't manufacture any car anyway. You don't manufacture a lot. So if they stop manufacturing, you don't have any car to use. So, but this is big. This is going to be big.
Very
big.
Thank you, Professor.
We have a question. Bonato, can you make a question, or you can you?
Yes, please. I think you can just read it and we'll listen the comment.
Yeah, so the financial institution and strong market player drive the main economic interest. People and environment comes after. If possible, opportunity. Please comment on that. Thank you. Yes, I think, all right. So when you talk about financial institutions and strong market player, at the end of the day, these are people. So we are not taking these guys from the zoo to come and run our financial institution. They have not come from wherever. Even the politicians, they're still part of the people. And what is important is that we do have a common ground where we know that things like environment, for example, is good for us. We need to begin to talk about that message, that it is not just about technology. It is not just about installing new things in the city. It is about our well-being. So when we talk about environment, you go to some countries, okay, you have to close your nose because you cannot breathe very well. Some cities in the world. Then you go to another city, you have very good, air to breathe. That is already a good measure of the fact that if we pollute our environment, it is not the environment that is suffering. We are suffering. So it's really stupid for us not to do something about it. Right? So what I see as complementary in the role of the technology and the people is that the people should be part of the decision, not when it has already been done, but actually at the design level, that this is what we need. This is what is good for us, okay? Not somebody like Professor Moses telling us this is the sensor that is good for you, and then he develop it. No. People on the street, people selling bread, people in the restaurant, everyone, they should be part of it to say, well, let's have a conversation like democratization of decision when it comes to technology. I think that will move forward. And I think the market players and the financial institutions, we have no choice, because once they begin to see that, well, that is where the people are going, they have no choice, because in any case, they are part of the people as well. And I don't think they want to die. They want a good well-being for themselves as
well. Any more questions? Oh, Gilmar Barbosa, please go on. Go ahead. Gilmar?
Yeah, I did my question already, Professor.
Okay. Deli, I have a question. I mean, what you have just said remind me about, in the communication field, you used to have like, we need to get, in terms of communication system, you usually, one requirement is to quality of service. It means that, okay, let's design the equipment that ensure this QoS.
Yes.
But nowadays is quality of experience, right? QoE. Yes. It means that what is good for the users is not actually, I mean, for instance, is the quality, you are not worried, the idea is that the design of the equipment, everything there, should result in a good quality for the end users. For instance, okay, if I'm watching a movie or or watching a news on TV, there are different constraints about that. For instance, I'm watching a Champions League final. Oh my! I mean, I need, the quality of experience for me is that I cannot lose any frame, for instance, because it's very relevant. But it's about a daily news. So quality of experience means that we need to thinking about the end user or designer experience.
Exactly.
So that everything is designed from that perspective. Okay.
Perfect.
That's a good analogy, right?
Exactly. So the whole thing is that, but you see, unfortunately, when you look at, we come up with a new technology. So there's OFDM, there's AI, and all this terminology. Sometimes it comes from scientists, it comes from academics like us. Okay, and what we do is we go to the industry, and sometimes they buy into it, and then it is when we have developed it in a corner, we then push it down the throat of average people on the streets. Say, well, this is a new technology for you, it's good for you. And of course, sometimes they just accept it as one. But really, the complementary role of people in all this is that they should be part, they are designers, they are as good as you in the designing of that solution. And you will see many smart city projects fail in the world. I have the one in Canada, some in the US. They tried because they've interviewed me before. They came to see what we are doing actually in the UK. Many failed because of this. Because I'll give you an example. When we first started this project, one of them, the one called Triangulum by EU, was for 5 years. Can you still hear me?
Yes.
Okay. If that project were to be like 3 years, I think it would have failed. And I will tell you why. The first year was mainly about argument, understanding ourselves. Because the proposal was not written really thinking too much about people. It was more about, there's this new solution. Until we went to one place and we said, look at this free battery. Okay, it's free. Look at this. We want to install it. And they said, no, we don't need it. Because if you install it now, it's going to attract some people and it's going to affect our security. And you can see, if you are thinking for people, you might even think you are doing them a favor. You are giving them something for free. But what you are giving them for free, you think is free, is not good for them. Okay? So any project failed all across the world when they started with Smart City because they are throwing solutions and technology at people and, it doesn't work. So I think I want to answer a question from Francisco.
Yes, and also I think that Bruno Gia has raised his hand before.
Okay, so Francisco asked a question about UK legislation on energy trading. Actually, the two projects, by the way, were funded by government. But actually, I'm working on one right now, which is energy trading, a local energy market in Manchester. which have been contracted by my team to look into. Again, is by government. They are throwing a lot of money into this. Part of it is that they want to understand how to be. Your question is also about legislation, how to change the legislation, because the legislation limits you only to below 1 megawatt of energy at the moment. So you cannot share energy more than that. So they are looking at research to see how safe it's going to be, how it's not going to cause instability in the network when they allow it to be more than that. Okay, so we are looking into that as a research. But yes, UK government is backing this 100%. In Nigeria, we are using that demonstration site now to convince people hopefully convince people in the legislation to also change the rules a little bit so that it allow, they will allow people to do it in a larger scale.
That's great. Bruno, can you talk?
First of all, thank you so much for your nice presentation and very motivating one. Well, we could discuss for a long time because I've been working with peer-to-peer and also with electric vehicles.
Fantastic!
This topic, yes, and I really love this topic, electricity markets. But I could raise a couple of a dozen of questions, in fact. But I'd like to ask you for a little bit for some points on your peer-to-peer projects, because I've already talked about the vector grids. But first of all, Francisco asked about the regulatory things, and did this project was implemented as a sandbox, a regulatory sandbox in Manchester? Was that?
Yes.
And well, I'm asking that how people interacted in a peer-to-peer, because nowadays we know that from behavioral economics that people tend not to go further in the trading because, well, they don't want very much to understand about energy things and those, and Texas has given us a very good example of how things can, if you really implement a market, how things can go very badly, isn't it? And my main idea was how those people interacted in this scheme of peer-to-peer. I think this is very...
Okay. Bruno, I think I get your question now. So was this implemented in the UK? No. All right, because it is very difficult. And this is why I say to you, we are privileged because we're able to do it in Nigeria. So in Nigeria, even in Nigeria, the legislation, right now does not permit officially for us to do it anything above megawatt. So what we did was we call it a private wire. So actually, the 10 buildings and the school, they are hardwired, directly hardcore wired. In real environment, so it's good for experiment, but in real environment, it will not be hardwired. Go through switch gear and everything, right? So, but we couldn't do that in the UK for now. But we're actually taking. So what we did in UK is more paper writing, algorithm, and all these things. And this is why I lose interest because it's never going to go to market. So I was really glad that we took it to this Nigerian one, and we are now taking it back to the UK because many institutions, as soon as they saw that we were able to implement it, they are coming back to us now asking, can we try it? Can we try it? So the campus I showed you earlier on, we want to now try to use that as a test bed for peer-to-peer energy sharing. We wanted to do it 3 years ago. It was not possible because there is a rule that our battery is not allowed to take anything to the grid more than X amount, maybe 100 kilo, something ridiculous, too low to do. So we're trying to change all that for research purposes. So we've not done it in the UK yet, but we've done it in Nigeria.
Oh, that's fantastic. Very nice to hear about that. And so you have implemented a scheme of behind the meter in Nigeria, isn't it?
Yes.
So we have decided to put everybody behind the meter and then implement it over there.
Exactly.
Perfect. And how people interacted in this scheme?
Okay, so
centrally controlled.
Yeah. So the Nigerian one is very interesting because these are people, they didn't have energy at all. So we did one energy as a service in Canada. I didn't show that, but we have another project which is with Canada. All right. So that one is people, they have energy, they want to use more green energy. Okay. So we do a bit of peer-to-peer, but trying to harness more green energy. The Nigerian one, I would say maybe not too complicated. Why? People in that village, yeah, the 10 people, they have electricity maybe only about less than 5 hours a day, and some, yeah, a whole day. So for them, when we give them excess, maybe additional 10 hours, so now they have 24 hours, okay? They don't care too much. They don't think about selling. All they want is they have electricity, and at the end of the month, you charge them little money. Now it's free anyway, but we show them how much they will have been paid if we were to charge, and they're happy to pay that. Okay, so people are engaging, people are interacting, people are, and by the way, people don't need to interact too much, by the way, because all this will be automatic. For the Canada one, what we tell people is, look, how much is your bill now? Very simple at the beginning. How much? You tell us £100. And we say, okay, you will pay £70 maximum in the next 1 year. So because people can see 30% decrease in their energy usage, they can also see that they are using more green. They don't care. So we do the decision, okay? Not them. People don't do the selling and sharing. We do the selling and sharing with the grid, with the people, and so on. At the end of the month, we charge you £70 instead of £100. Maybe it costs us £50 or £60. We make the £10 for our platform and the trading. Remember, we are buying energy in bulk, all right? So it's easier for us to do all this manipulation. You are happy, we are happy, the environment is happy, everybody is happy.
So the idea is to have something like an agent to trade energy for you. Okay.
Exactly.
Fantastic. Thank you so much. I could talk to you for a long time, but
yeah.
Let people ask their questions. Thank you so much.
So last week I was in Kenya. Actually, I was invited by African Union institution to address them on this. Same, when I was talking, everyone was, because if I didn't get this funding to go to Nigeria, I think it would be difficult to implement, because in the UK, people are skeptical. And by the way, they have electricity. Why do they want to risk and do more research that is too dangerous and they don't know the benefits? But the people we took it to, they need the energy desperately. So they're happy to risk, to say, okay, let's try it. And now we see that actually is beneficial.
And you gave me some thoughts, a very interesting thought. That's maybe this is the energy transition for underdeveloped countries. Maybe from this path we could promote this, isn't it?
I agree, but I agree. It's for developing countries, but actually for the developed, right? We are wasting energy anyway when you generate far away and you are transmitting over several kilometers. When you can generate it locally and consume it locally. So even for green, for the climate alone, you are good. For cost, you are good. The cost of laying cables all around. So it is a win-win for everybody. Nobody is losing here. Okay, nobody is losing.
Okay, thank you. And now we have a question.
Professor Bruno, especially when you now bring electric vehicle. Electric vehicle is always parked near to you. So you park it in the morning at work, you go to your office, 9 hours, you don't come back. So it's fully charged. You drive it home, 15 minutes, 20 minutes, you get home, you go sleep. Okay? Car is the main thing you buy in life that you never use. You spend a lot of money, but you never use it. Think about calculate the amount of time you are inside your car. It's so low that maybe you shouldn't have a car, but we have it anyway for status, for convenience. So that part now is going to change from convenience and status to investment. So you buy it and you are making money when you are sleeping. You are making money when you are in your house. It's amazing. Now, think about another thing. 1,000 cars in your car park at Jules de Fora University, right? How many cars are in the car park? Maybe 6,500. Maybe imagine that we can connect all the cars together as a battery, yeah? And we use that to power the university.
Fantastic.
Exactly.
Very nice. Thank you so much.
Look at the number of cars at the airports, and so on. Anyway, so it's interesting. Peer-to-peer is going to be very big. I believe it's going to be very big.
Fantastic.
Yeah.
Now I have a final question from Professor Bonato. He said, how to design a truly smart electricity market where the socioeconomic welfare of people are at the center? how to balance the conflict of interests. There is no smart city with sustainable inequality among people in the same market city country.
Okay. So
Can you
I
comment?
actually, Professor, I answered this question right from the beginning. And my answer to any question like this is really any technology. So this is technology. This is well-being. Anything that you apply, you pay your money, okay, that doesn't improve your well-being is useless. So don't do it at all. Why do you spend your money and effort not to improve your life? Why would you have an app on your phone that is showing everywhere you go and is exposing you to armed robbers and you're going to be kidnapped? So why do you need it? It's a useless app. Delete it, all right? And I think it's the same, in my opinion, for every technology. And the way we can avoid all this is people being involved, like I said. But think about it this way. Again, always I say this. IoT should make your life safer. Why? Because yes, you have armed robbers. Yeah, you have cybersecurity people that are trying to steal your data. But remember, without IoT, they were trying to do that in a very simple way anyway. All right. Now that you have IoT, they want to do it. You have good people that are trying to secure the IoT to kick them out and get them in jail. All right. So the same, the peer-to-peer and smart city, yes, you have socio-economic imbalance, you have all these interests and so on. But when we are there and good people are voicing their opinion to say, no, it has to change. This is the right way. We discover that actually it's a better way. And I will give you an example of why it is better. The one that we deploy in Nigeria, right? We realized, I didn't show the picture, but we realized that we selected 10 houses. What is the condition for selecting the houses? Closer, because you remember we want to lay cable, hardcore cable from the school. So it's expensive to take it too far away. So we selected the 10 houses that are too close to the school, all right? But as we're doing it, we realized that more people who are not from the 10, they go to a particular shop. So we connected the shop as well, all right? We realized that, okay, more people go into a particular mosque, okay? It's now a community, not just one person on it. We connected it, and we give those two free of charge. Do you get me? So actually, peer-to-peer energy trading can help solve inequality problem. How? Good. When I'm going on holiday and I have electric vehicle and I have solar panel, for the next 2 weeks, my energy is wasted. I could just say, instead of selling it, I have money. I'm comfortable. I'm not millionaire, but I'm comfortable. I don't want to sell this. Anybody poor in my community, I want to dash this away. I want to give it to the community. I want to give it to that old woman, old man that is on pension and doesn't have money. Let them use my electricity for free. That is why we call it peer-to-peer trading and sharing. Because it is not just about selling, it's also by giving it for free. Okay, so people can donate the electricity. It can be, and like this school, for example, they can make it their corporate social responsibility. So we are talking to a company in Nigeria, they make big beer, a very big factory. So say, look, if you have solar panel on your roof and so on, you may not be able to consume them in the evening. You can donate it. You are rich. It's a big company. Make it your social corporate responsibility for people around you. So actually, this technology can solve this problem instead of adding to the problem. It all depends on who is on the table and us believing that in a democracy, we have a voice. And actually, we have a voice. I know I have only one voice, but everywhere I go, I insist that, look, any technology that is not helping people's life is useless. Don't do it. Number one. Number two, people must be part of the design, not just users. They must be part of the design. They are designers. They are not users.
So I think, okay. I think that, Deli, I think that I wish we could spend more time, but it's time to go. Once again, I'm delighted having you here and giving very nice talk and also for excellent discussion. And I think that it opened our mind for everything, for other ideas. And I'm glad that the other colleagues from INERGE who are here could see something that maybe you can collaborate in the future. So thanks so much, Danny,
everyone.
And have a nice night. Bye-bye, everyone.
Thanks a lot. Thanks. So,
Bye-bye.
Professor Jazz, Bruno Jazz, we can be keep in touch.
Take
All the
care.
best, everyone. Thank you.
Thank you so much.
Cheers. Thank
Bye-bye,
you.
Danny.
Bye, bye, bye.
Bye-bye, guys. Okay. Oh, it's still recording. But someone can stop recording? Alguém pode parar? Ok. Ok, obrigado.
Muito bom.
Ô, Bruno, foi bom, né? Legal, né?
Muito legal a apresentação dele, muito boa.
Você vê que é um pessoal que ele não tem um perfil de